Hey guys, welcome to the video notes on exponential growth and functions. We're going to begin this lesson, again like we do in class, with the do now. Remember that this video is to support what we've covered in class, so if there's something that you missed or you might want to look over, please feel free to scroll along any part of the video that you just want to focus on and then get that example done and feel free to click out. If you want to learn something new, go ahead and stay through the entire lesson and maybe you'll pick up something you didn't hear in class. So let's get started. In the do now, I have a bunch of vocabulary terms on this side, and I want you guys to match them with the definitions. So the first one we have up here is asymptote. We've covered this one in class before, and we said that it's a line in our graph that never gets touched, or it never gets touched by our graph. So let's go ahead and match that one up with B. Horizontal shift, when we're dealing in general forms, our horizontal shift is given to us by our H value. H for horizontal. And then we have vertical shift. Our vertical shift is given to us by the K value. And the last one we have is a horizontal asymptote. So horizontal, again, it means it's side to side, horizontal. So that variable, or actually that value, is given to us by the K value as well. If we think about it in terms of graphing, we know that Y is equal to our K value. And that's how we get our horizontal asymptote. Cool. So then for the second part, we have to apply the shift to the following points. So the shifts that we're talking about is our H, that's our horizontal shift. So that's 3 units to the left. And our K, or our vertical shift, and that's 1 unit up. So here we're given 3 points. So I'm going to take each one of these points as an individual case and then apply my shifts. The first one we have is 5 and 3. So if I'm going to take this, or if I'm going to apply my horizontal shift, I'm going to move this 3 units to the left, 1, 2, 3, and then 1 unit up. This is our point, or our new point. I'm also going to do this to this point. We have 1, 1, so I'm going to shift it 3 units to the left, 1, 2, 3, and then 1 unit up. Here we have our second point. And the final one we're going to apply is 1, 2, 3, and then 1 up. There we go. We're good to go. So that's how we applied our vertical shift and our horizontal shift to all of these points. So the title of this lesson is Graph Exponential Growth and Functions. So our objective is given an understanding of graphing ordered pairs, something that we've done before and in the previous lesson, and asymptotes. Students, meaning you guys, will be able to graph and use exponential functions to model exponential growth and compound interest. So what does this all mean in English or in student talk? It means that students, you guys, will graph. So we'll begin by looking at graphs. So we'll graph exponential functions and write exponential growth models and models, or compound interest models. So students will graph exponential functions and write exponential growth models and compound interest models. So let's jump into the next slide. It's a few vocabulary terms. We're going to be dealing with exponential functions. That's a function written in the form y is equal to a times b to the x, where a cannot be 0 and b, our base, is a positive number other than 1. The next term we have is exponential growth function. So this is the general case, and this is what a growth function looks like. Growth function is going to be a function of y equals a times b to the x, where a has to be a number greater than 0, and b has to be a number greater than 1. So a quick example of this is y is equal to, let's say, 3 times 2 to the x power. 3 is greater than 0, and 2 is greater than 1. And then we have the vocabulary word growth factor. Growth factor is just the vocabulary word for the value of b. So this graph will actually be growing by a factor of 2. So let's take a look, or let's analyze the parent function. The parent function of our exponential growth function looks like this. It's kind of a curve. It actually reminds me of a half pipe. So if we think about a snowboarder or a skateboarder, here he is. He's actually going to go up this thing in an exponential curve. So this is known as our exponential curve. Just kind of erase this little dude here. All right. So our parent function, anytime we're given a parent function, it resembles this equation. It's f of x is equal to b to the x. Well, when there's nothing written in front of it, it still has an a. In fact, there's always something written, a number written in front of it. That number is 1. So a will equal 1. A few things to notice about this graph is that our y-intercept crosses at 0, 1. So this is 0, 1. Our y-intercept is actually given to us by the point 0 and a. So this point is our y-intercept. If we look up here, we said that a is equal to 1. So when x is 0, our y value is going to be 1, or our y-intercept is 1, and that's where we get this point. The second point we want to look at, all exponential graphs will pass through these 2 points. Every single exponential graph will pass through these 2 points. So the second one we want to look at is when our x value is equal to 1. So if we look at our parent function, if our x value is equal to 1, then y, we still have that a and that b. So y will equal to a times b. And this is our y value, a times b. It just so happens that in this parent function, a is equal to 1, and we don't know what b is. So our point would be 1, b. And that's where we get this point from. 2 very important points. Something to also notice about our exponential growth graph is that it carries an asymptote with it. Our asymptote happens to be the function y is equal to 0. And it does have something to do with our k variable or our k shift. And we'll look at that a little bit later on this lesson. So let's move on to an actual example. So here we want to graph when a is equal to 1. We want to graph the equation y is equal to 2 to the x power. So y is equal to 2 to the x power. So whenever they give us an equation and we know that a is equal to 1, what we usually want to do is to create a table. Since we don't know anything else about graphing these exponential graphs, when in doubt, always do a table when you need to graph something. So I'm going to go ahead and create my table. I have my x values here, my y values there. I'm going to pick about 5 points. So 1, 2, 3, 4, 5. Okay. I want to start with 0. So let's go ahead and plug in 0. So when we plug in 2 to the 0 power, we know we're going to get 1. 2 to the 0 power. Yeah. So I'm going to pick 2 points to the left of 0 and 2 points to the right. So I'll pick -1, -2, +1, and 2. When we substitute 1, 2 to the first power is going to just give us a 2. And then 2 to the second power will give us a 4. If we plug in the negative values, we get a 1/2 and we get a 1/4. So now we have a bunch of ordered pairs, or actually we have this relation. We have inputs and outputs. So I'm going to go ahead and graph these points and then see what our curve looks like. So we have that 0, or we'll start with -2. At -2, we're going to go up about a 1/4. So that's about here. The next one we have up is -1. -1 is going to be about a halfway up. So there it goes. At 0, we're going to go to 1. Here is 1. At 1, we go to 2. Here is 2. And at 2, we're going to go up to 4. So you see how we kind of begin to develop this curve. And again, our asymptote is going to be the x-axis. So we're not going to touch the x-axis. I'm going to try to draw this curve as close to the x-axis as I can without ever touching it. And there it is. This is what an exponential graph looks like. So a lot of people like to use the term it grows exponentially without knowing what that means. Well, this is exactly what it means. It's growing by powers. So our base is 2, and all of our variables are going to be powers. It's going to grow exponentially. It grows really, really, really fast. So now let's take a look at another example, or actually, here's 4 steps that we use to graph every single one of these exponential values. If we follow these 4 steps, we can graph every single exponential value. So step 1 is list all variables, or all the values of our variables. Step 2 is to plot 0 and our a, which is also our y-intercept, and then plot 1 and a times b, which is our second point. We covered 2 very important points. Step 3 is apply any shifts if needed. Sometimes we have shifts, sometimes we don't. And step 4 is draw a curve and mind the asymptotes. So let's keep the asymptotes in mind. We'll see them further on. We'll see the bigger role they play further on this lesson. So here we have example 2. We want to graph when b is greater than 1, or we're starting to look at equations when our value of b is a higher number. So now we're given an a and a b value. So if we follow our 4 steps, looking back, we want to list all values of our variables or the variables given. So let's go ahead and do that. My a value is going to be 1/2. My b value is going to be 4. I don't have an h value and I don't have a k value. In fact, we haven't even covered those yet. So if I know those 2 points, looking back, I'm done with step 1. Now let's look at step 2. It says plot my y-intercept, or 0a, and 1, comma, a times b. So my y-intercept is going to be 0, a, and y, a times b, well, that's just 2. 2 very important points. Here we have 0, 1/2 is about there. And then the other one is 1 and 2. 1 and 2. So we have those 2 points. So we know that this graph is going to look like a small curve, or kind of a, what I like to call a half pipe or a ramp. And we're not going to, and again, our asymptote is going to be our y-axis, our x-axis. So it's never going to touch our x-axis. Here it is. So let's see if I can draw this really close without touching. Sketching it out. I'm going through this point and that point and getting very close. There we go. There we go. And we're done. Way easier once we've got the steps down. So we're going to scaffold this in class. We're going to actually take a look at 3 different examples. Again, if you guys are kind of iffy on it, not quite sure, go ahead and try the red one. If you guys feel a little bit comfortable with it, try the yellow one. If you guys feel really good about working these examples, try the green one. For the sake of time of this video, I'm going to run through one more example in case you guys needed an extra example. So let's go ahead and work out the green one, the harder of the 3. So just to kind of prep for it, let me go ahead and draw my y and x axis. We're going to go 1, 2, 3, 4, 5. Here's x. 1, 2, 3, 4, 5. Here's y. 1, 2, 3, 4, 5. Remember that's a negative. And 1, 2, 3, 4, 5. Remember that's a negative. Positive, positive. I urge you guys to use straight edges, or the edge of your ID card works just as fine. So we want to go ahead and follow our steps. We want to list all the values of our function. Remember, we're doing the green one. We want to list all the values of our function, or the ones that are given to us. So here we have a is going to be equal to 1/2. B is going to be equal to 3. We want to plot our 2 points. We have 2 very important points. The first one is our y-intercept, which is when x is 0, y is 1/2. The second one is when x is 1. We just multiply these 2 together, and we get 3/2. So let's go ahead and plot these points. 0, 1/2 is about here. And the other one is 1 and 3/2. So 1, that's about 1 and 1/2, so it's 1 and 1/2 is right here. Okay? And we know that our asymptote, again, is going to be the line y is equal to 0. So that's our asymptote. It's going to get very close to it, but it's never going to touch. Our curve is going to curve slightly like this. And we have our little half ramp, and we're done. Cool.